Let's do an example where you have to test a one-tailed test. So I'm going to do the model with just the sales price of a house with bedrooms as a variable, and there's numerous other variables: lot size, square feet. So here's the original econometric model. And let's suppose I just want to know, do bedrooms increase price? Which of course we expect them to. So if we get an estimate for the slope coefficient on bedrooms of 11.60 roughly, and let's say we have a standard error that is 6.55, then if we're setting up this hypothesis, we are not setting it up as two tails, we're setting it up as a positive, just miswrote that. A positive effect on price needs to be in the alternative hypothesis, and we can set equals to 0 with no effect as the null hypothesis. So because the alternative is a greater than, it's a one-tailed test. Let's suppose that we're going to use a 10% level of significance. Again, that's probably the largest it would ever be, but I don't necessarily have a great model I'm working with. Then we're going to have our t-test. It's found the same way as a two-tailed test. Makes no difference. We'll have 11.6. We'll still have 0 because that's what's in the null and alternative. And our t-test is around a 1.77. So that's basically, remember, t-test is telling us what did the model give us, whereas we're going to use our p-value versus level of significance in terms of what sort of criteria do we find acceptable. So this is consistent with the null hypothesis. My t-test is at 1.77. The question is, where is that in relation to my standard of proof that I'm requiring? So in our model, if it's a 10% level of significance, but if we have a greater than right here, that means our whole level of significance is on one side. The tail for a t-test on one side would come from our output, but it would have to be, because we're only putting it on one side, the output always tells us the total p-value. We only want the area on one side. So if the output said around a 0.08, what that means is it's assuming a two-tailed test, so it's assuming there's 0.04 here and there's 0.04 on the left side for a two-tailed test. However, we're doing a one-tailed test, so we're comparing 10% alpha on one side to 0.04 on one side, and p-value is clearly smaller than alpha in this case. So since p-value is less than alpha, this is 0.04, this is 0.10, we reject the null hypothesis. And rejecting the null hypothesis, basically this statement is all true, but whenever I say what's this conclusion or how is this applied to our story, what we're saying is we have shown that there is a positive effect of what were we doing? Bedrooms. Positive effect of bedrooms on sales price at a 10% level of significance. Another way to think about our p-value again is how much smaller could my level of significance get so that I would barely be able to reject the null. So if I lowered alpha down to 4%, that's right where I can reject the null. But if I tried to be more stringent, such as alpha is 1%, then I wouldn't be able to reject the null. Just as a reminder, it's t critical. That's the distance from the null hypothesis for the rejection region. T-test is a distance from the null hypothesis for the test statistic. Alpha is an area that goes with t-critical, and p-value is an area that goes with t-test.